All right, example 4. Here are our very small populations again, A, B, and C. Estimate the sampling distribution's means and compare them to the population's mean. Which standard deviation is smaller, the population or the corresponding sampling distribution? All right, so I'm just going to renumber these again. Okay, and let's estimate these means. So here the mean looks like 30. Here the mean looks like 30. And here the mean might be a little bit greater than 30, but still around 30, so maybe like 31 or something, right? And here the means are 30, 30, oops. Maybe I'll put these in different color so that you know I'm talking about the population. So here we know the mean because it's 30, 30, and 30. And what we see is that the sample means, even though our n is small, our n is only 2, right? Equals 2. Even though our little n is small, well, I guess our big N is sort of small too. Here we see that the sampling distribution of the mean, right? The expected value is very similar to the actual population mean, right? So estimate them, compare them, very similar. Okay. So which standard deviation is smaller, the population standard deviation or the corresponding sampling distribution? Well, it might be helpful if we actually find out what the population standard deviation might look like. So here we have something like, so here's A, B, and C. A is 10 and 50. B is 10, 20, 30, 40, 50. And C is just 20, 30, and 40, right? And so let's find the standard deviations of these populations. Okay? The reason why we use standard deviation of the population is because we want it to divide by n rather than n minus 1. So we could just put in all of those. Oh, actually. I wanted to test and make sure I could use these blank ones because then I could just copy and paste across. Okay, so the one that has the greatest spread is A. The one in the middle, population here, this one has the middle spread and this one has the least spread. It's sort of closest together. All right. So just to give you an idea, this population standard deviation is 20, right? The spread is 20. But if you estimate this, is this less than the standard deviation of 20? Or greater, right? Well, if you think about a standard deviation of 20, right, that would be this. And another 20 would be that. And usually within 3 standard deviations, you have the entire like almost 99%, right? But here what we see is already at 1 standard deviation, you have almost everybody in there, right? So I would say this standard deviation is smaller. So here, mu sub x bar, that's the same, but sigma sub x bar, I would say, is probably smaller than sigma, right? What about here? So here in, this is now corresponding to B, right? B, A. So here, the sigma will be something like 14, right? And so if I go out about 14, that would be like that, right? 1, 2, oh wait, sorry, that's not 14, that's 5. So 14 would be that. 1, 2, 3, right? And even when I go out to about 1.5 standard deviations, I've basically covered my entire space, right? So here, although the mu sub x bar is similar, our standard error is smaller than our standard deviation of the population. And let's use that same logic for the last one that has a standard deviation of approximately 8, right? And here, let's go out about 8. So 8 would be like that, that, right? And again, we see that although the mu is similar, not exact, but similar, our standard deviation, or our standard error, is less than sigma, right? So one thing we find is that typically the population standard deviation is smaller than the corresponding sample distribution's standard deviation, or what we call standard error. All right, so that is your introduction to sampling distributions. Thanks for using Educator.com.